I made a three-legged walking robot, and it went exactly how you'd expect. The goal of this project is simple. I want to create a walking robot. I toyed with a lot of ideas and eventually settled on 3 legs. The reason for this is that I haven't seen any 3-legged walking robots before, and it would be a cool challenge. I have a few ideas of how I can do this. Here are the initial sketches I made to come up with some ideas. My first step was to look to nature and see if I could find any instances of 3-legged walking animals. I didn't find any 3-legged animals, but I did notice that when some animals run, their back legs move together almost like a third single leg. I tried to imagine how this would work in my robot, and of course I had to experiment. I have 2 main ideas at this point. One uses a Jansen linkage, which is a bunch of linkages that are pinned together and it has a single motor that moves in one direction to create a repeatable step pattern. My other idea is to use a parallel bar mechanism. This gives me a lot of freedom and a lot more power as there are 2 motors here. Each motor moves independently and can move the foot in any path or in any location. Here's the design for the walking robot. I decided to use the parallel bar linkage because it can provide me with more power and has more flexibility in the gait. The design is pretty simple. I have a flat chassis that I can mount all my components to. The reason I did this is that it should be pretty strong and will allow me to modify the design easily, and I can make the design super modular. Now let's get to the build. So I'm finally finished printing all of my parts, installing all the heat inserts, and I'm ready to start assembling. The bottom of the assembly is finally complete. I had some tolerancing issues, which meant that I had to drill out all the holes so that my screws would fit. I was also lazy in my CAD and didn't model my cables, so I had issues plugging into the Raspberry Pi. Luckily, this was nothing that the saw couldn't fix. It turned out to be taller than I had imagined, and so far it has been surprisingly easy to build. All that's left to do now is add to the top plate and finish wiring the electronics. Now that the hardware is all put together, it's time to get the motors moving and see if I can make this thing walk. So, I'll save you all the talking. Basically, what I'm trying to do here is get the legs to move in sync together in a sinusoidal pattern that will allow the robot to walk. The first thing that I did was home the motors to the middle of their ranges, then I was able to attach the legs and test the limits of the range of motion of each leg. Basically, I spent a few hours kind of randomly playing with the motors to see if I could get a gait that looks like walking. There are definitely more efficient ways to do this, but at this point I just wanted to see enough to know if the design could move how I wanted it to and see if I could get close to walking. All that said, let's see if this thing can walk. Just for the hell of it, I'm gonna try it standing up. I have a feeling it's just gonna tip right over, but I'll be prepared to catch it. So yeah, that didn't work.
So, after watching all the footage, I realized that I had this motor on backwards the entire time. I went back and changed it on the physical robot.
That made a huge difference. It still can't walk, but it feels like it wants to. I think once I change up the center of mass, tighten some tolerances on the back leg, and add some feet with more friction, I might actually be able to walk.
The new design hasn't changed much. I've shifted the battery forward to improve the center of mass, and I've widened the base so that it's more stable. I've also added walls around the chassis to make it more rigid and to protect the electronics and motor better. I've also adjusted the lengths of the legs so that it's more stable and more balanced, and I've added holes to the bottom of the legs where I can mount feet so that I can have better friction and modify the feet rapidly if I need to.
Just like last time, I 3D printed all the new parts, I milled out the new chassis and drilled all the holes. I used heat set inserts again because they made assembly and disassembly really easy and seemed to be really strong. The build is pretty simple. I pretty much just gutted the old robot and transferred all the parts to the new chassis and mounts. And I have to say, it turned out great. I love the way it looks and how nicely everything fits together. Now, if only it could walk.
Now that the design has been changed, it was actually really easy to get the robot moving. Off camera, I manually moved the legs in what I thought was a good leg motion, capturing the angles of the motors at key points. I put this data into a MATLAB script that allowed me to get a starting sinusoidal function for each leg. From here, I could modify a few things to troubleshoot the walking. I could change the offset, or the center of the motion of each leg, I could modify the total angle, and I could modify the overall speed of the motors. It seemed like my biggest obstacle at this point is friction. I actually had to move weight back in the assembly, which I did by re-drilling mounting holes for my battery at the back of the chassis. I also added a back foot with sandpaper glued on so that it could have more grip. All that said, here's kind of the sliding walk I was able to get. I want this robot to walk on terrain other than a smooth table though, so it's time to brave the outdoors. So here I am out in front of the Duke Chapel about to test the robot for the first time outside. It starts out okay, it's just kind of jumping around back and forth, and then crash. Luckily, everything turned out okay. I was able to keep testing, but every time that I ran it, it would just go backwards. As a last-ditch effort, I tried reversing the direction of the front motors. And that didn't work. Time to go back to the drawing board. After a late night in the lab, I was finally onto something. It can pretty much walk on rough ground outside. Every time it falls, it seems like one of the legs gets caught on the rough ground or fell from stepping on ground that wasn't quite level. I moved to a spot where the ground was more level, and it actually did pretty good. I still had to walk next to the robot to make sure it didn't fall, but it actually went decently long distances before it would fall. To get to this point, I had to change the gait so the back legs had a much larger range of motion, and I added front feet to the robot so the legs wouldn't get caught on small inconsistencies in the ground. Here you can see the robot actually goes the full length of the camera view without me touching it. Does it walk? I'd like to say it does. I think I'm finally happy with how it turned out, and I don't think it can get any better unless I make some serious changes to the design. Overall, this robot has been super fun to work on, and I think I can say that I succeeded in making it walk, just like how I imagined from the beginning. Thanks for sticking around and watching this build.